Welcome back to TextConnect. In this video, we'll be discussing about solution spinning. So before moving on to the main topic, let us first understand the type of polymers that will be used for solution spinning. So as seen in the previous video, the polymers that can be melted, usually the thermoplastics, are melt spun. Now there is another group of polymers called the thermoset polymers. On heating, these polymers hardens and undergoes an irreversible change. The structural changes are permanent and thus these polymers cannot be melted. They either degrade on melting or the melt is thermally unstable. So obviously we cannot melt spun these fibers and we need a different system for them. So the solution here is solution spinning. The polymer is dissolved into a solvent, the filaments are then extruded and the solvent is then removed. Now depending on the solvent removal process, solution spinning is again divided into two processes. One is dry spinning and the other is wet spinning. In dry spinning, the filament is solidified by removing the solvent by evaporation when heat is applied. Now fibers like cellulose acetates, triacetates and some acrylics are produced by dry spinning. In the case of wet spinning, the polymer solution is coagulated in another wet bath. Now this fluid dissolves the solvent but not the polymer, and thus the polymer precipitates and the filaments are obtained. Viscose rayon, lyocell and aramids are some examples that are produced by wet spinning. So let us look into dry spinning in detail. The very first step is to prepare the spinning solution or dough. The polymer and the solvent are dissolved in mixers at 100 degrees Celsius or higher. Now when we prepare the dough, some impurities like water remain in it. This has to be removed by filtration. Next, deaeration process is carried out, which removes any air bubbles or any unreacted monomers that is presented in the dough. Now the dough is ready for spinning. There are certain conditions that the solvent has to fulfill. First and foremost, it has to be volatile so that it can be easily evaporated and removed. Now next, looking from the economic perspective, it should not be very expensive and increase the overall cost. And the dissolving power should also be good. We'll now understand the passage on a dry spinning line. The spinning dope is first fed into the chamber, which then passes through the metering pump. This pump only allows the required amount of dope to pass through it. After a filtration stage, it is forced into the spinneret. Now the filaments extrude through the spinneret holes and then it enters into the spinning tube. Now once the dope leaves the spinneret, it bulges. Now why does the filaments bulge? This is because the polymers are viscoelastic. That is, they store elastic energy. So when they are extruded, they release this elastic energy and thus a slight bulge can be experienced. Now to avoid filament breakages, optimum viscosity, temperature and takeoff speed has to be maintained. The viscosity is affected by the polymer concentration in the solution. So it has to be kept in mind while preparing the solution, because this also affects the flowing properties of the solution. Now in this diagram, we can see that the tube has a jacket of heating fluid surrounding it. Now this is to maintain its temperature. The drying gas also enters the chamber and flows in the direction of filaments. Our main objective here is to heat the filament bundles above the boiling point of the solvent in order to remove it. So once that temperature is attained, the solvent starts evaporating and thus it is removed. Now around 5 to 10% of the solvent is usually retained in the fiber system. So there are few precautions that we have to take care during this process. Now first and foremost, the chamber has to be leak proof. That is, no vapor should leak. Next, the density of vapors should not exceed the safe limits and the risk of explosions have to be taken care of. So the outlet for drying air sucks out the air in the chamber and it also recovers the solvent vapors, thus maintaining the density within the chamber. Now, after this, the yarn passes over the spin finish applicators and it is then wound at a speed of around 200 to 1500 meters per minute. Now we saw the spin finish applicator. So the spin finish is applied on the yarn for a number of reasons. First, it increases the cohesion between the filaments. Then it also reduces the friction and reduces the static charge accumulation on the surface. Now let us have a look at the fiber cross section. In melt spinning, when round spinnerets are used, we generally get a circular cross section. But in the case of dry spinning, whatever is extruded is a solution of the polymer and the solvent. So when the solvent is removed, the fiber cross section is affected. So the solvent has to first diffuse to the outer layer of the filament and then it evaporates into the chamber. So this distorts the cross section of the fiber. The balance between the rate of evaporation and the rate of diffusion decides the fiber cross section. Now when the rates are almost equal, then a nearly clear circular cross section is formed. The greater the evaporation rate, a harder surface skin is formed on the fiber. Now when the evaporation rates are greater than the diffusion rates, serrated cross sections are formed. Whereas flat or thinner shaped cross sections can be seen when the evaporation rates are much greater than the diffusion rates. So this was all about dry spinning. Now let us have a look at the passage of wet spinning. So the solution preparation technique is similar to dry spinning. In this case, the polymer concentration is between 10 to 30%, that is less compared to 15 to 45% in dry spinning. Now this is because the wet spinning is carried out at a lower temperature. The dope is fed and then degassed to remove any unreacted monomers and filtered to remove impurities, and then it is homogenized. Now through the metering pump, the dope enters into the spinneret. The temperature and the pressure conditions are lower compared to dry spinning. In wet spinning, the spinnerets can have about 2000 to 50,000 holes. Now, the spinneret is submerged in a liquid coagulation bath. So the fluid prevents the filaments to stick together. And this is why large number of holes very close to each other are possible in the case of wet spinning. Now as the filaments extrude from the spinneret, they coagulate into the precipitation bath. Now this is the most critical stage, as during this time the structure of the fiber is formed. The solvent generally dissolves with the non-solvent in the bath and the polymer precipitates to form the filaments. So at this stage, the viscous solution is converted to an elastic rubber type solid. This is where the filaments are formed. This is where the polymer precipitates. So the filaments are then drawn from the spinning bath and the washing and drying processes are carried out. Spin finishes are then applied and then the yarn is wound. Now we'll wind up with a quick comparison between melt, dry and wet spinning. So talking about the production speeds, melt spinning is the fastest process with around 2000 to 6000 meters per minute spinning speeds. Dry spinning being slower between 500 to 1500 meters per minute, and the wet spinning is the slowest process having a speeds in a range of 30 to 300 meters per minute. Now in the case of melt spinning, no non-toxic solvents or any residues are involved. Whereas in the case of solution spinning, sometimes solvents are involved in wet and dry spinning, and sometimes toxic solvents are also involved or toxic residues are there in the process. Now both filaments and staples can be produced in melt and wet spinning, whereas in the case of dry spinning, only filament formation is possible. So this was all about solution spinning and melt spinning has been discussed in another video. So if you have not checked it out, then go and check it out on our channel. So this was all from my side. If you like the video, then hit the like button. Drop down your questions and feedback in the comments below. We'll be back with another video super soon. Until then, stay safe, keep learning and stay connected with TexConnect, a learning center for textile.